Hello everyone. Before we get started with the new lecture, I want to clear one thing from the previous lecture. So in previous lecture, I showed you an example of vertical shifting down, and in that example, we had y equal to x squared, the original function, and then y equal to x squared minus 3 means the whole graph is shifting down by 3. And then we have absolute y equal to x squared minus 3, but when you have an absolute value we cannot have any negative value. That's why whatever was in the negative portion of the graph, it has reflected into x-axis, and this is how the graph looks like. So the y-intercept has changed from -3 to +3. Now this is the main topic of today. So in today we are going to learn about vertical horizontal stretching and reflecting. So let's assume c is greater than 1 from the graph of y equal to f of x. Before that, I'm pretty sure this has been already covered in grade 11 and 12 as well, so I'm not going to go into that detail. So I'll just quickly review that. So if y is equal to c fx, stretch the graph y equal to fx by c factor. If it is 1 over cx, then shrink the graph vertically by c factor. If it is y equal to f of cx, then shrink the graph horizontally by c factor. If it is y equal to f of x over c, then stretch the graph horizontally by c factor. So one thing you can see from here, for vertical and horizontal stretch, the c behaves differently. So for vertical stretch, if it is a c f of x, is stretching, and for horizontal, if it is y equal to f of cx, then it's shrinking. And now y equals to f negative x means reflection in x-axis, and y equal to f of negative x means reflection in y-axis. So now we'll look into this example. The original, we'll try to draw sine x is equal to y equal to 2 sine x. So the original sine function looks like this. It starts at 0, ends at 2 pi. That's one period of the sine. But now because of horizontal shrinking, because sine 2x, which means we are going to have a horizontal shrink, that's why now our period will change to pi instead of 2 pi. Why? Because it's 2x. So that means we'll have a horizontal horizontal shrinking by factor of 2. So the original domain for the sine function was 0 x is greater than 0 or equal to 0 or less than or equal to 2 pi. So in the new function, this is how the domain will look like. 0 is greater or equal to 2x is greater or equal to 0 and less than or equal to 2 pi, and we know it's and then we divide everything by 2. So this is going to be the new domain of the sine graph, sine 2x. So the domain has changed, the period has been halved because we have a factor 2. So we're shrinking the sine graph horizontally by 2. Okay, so if you look into this graph, the period ends at 2 pi. If you see here, the period is ending at pi. Okay, so it has been shrinked horizontally, and every point has shrink. So every point from the original sine function, if you divide it by 2, then you will get this. Okay, so how we do it, I think you already know it, but still I'm going to give an example. I will make some space here maybe. Okay, so this is how you draw a sine function. So now we know the period is pi. That means, see, always divide the sine function or even the cosine function into 2 portion. So you know, between pi over 2 and 0 will be the maximum value. Between pi over 2 and pi will be the minimum value, and at pi it is going to be equal to 0. This is how you draw the graph, sine graph. So if it was an original graph, this is how you would draw. So we know the maximum period is 2 pi, okay, and another period is pi. So between 0 and pi it will have the maximum value, which is equal to 1, and at pi it will be 0. Between pi and 2 pi, another midpoint, it will have the minimum value, and then it will end at 2 pi. So now this graph was shrink by 2. That's why now our period has become shorter, which ended at pi. So that's why the graph looks like this. Hope that makes it clear. I'll move on to some few more examples. So 2 sine x means it's a vertical stretch of the sine function by 2. So the original sine function looks like this. The maximum value is 1 and the minimum value is -1. If you're stretching vertically, the maximum value will be 2 and minimum value will be -2. So this is the stretch sine function will look like. And then -2 sine x, which tells that reflection in x-axis. So this is how the original graph looks like. Sorry. So the original graph looks like this, and now if we reflect that into x-axis, this is gonna do the reflection. So now we have reflection in x-axis, and the last one is 1 minus 2 sine x. So we already found the reflection in x-axis, which is x-axis is equal like this. We found that from the previous example. Now we are moving everything up by 1. So the maximum point of the original graph was +2, and we are moving it up by 1. That means we'll have +3. Minimum point was -2, and we are moving it up by 1, so we'll have -1. So the new maximum point is 3, negative point is negative, minimum point is -1. Now the graph itself doesn't change. The graph remains exactly same. It's just moving up by 1. This is exactly same graph, just reflecting on x-axis, and this is just a vertical stretch. And this is how you draw a sine function. This explanation is very important, because you will do a lot of drawing of graphs in your lectures. So again, I'll just go over it quickly. So if your period 1 period is 0 to 2 pi, let's say from the original graph, so at the midpoint of 2 pi and pi, because you'll have 2 maximum in a sine graph. That's normal. So one maximum will be at between 0 and pi. There will be one maximum, and it's at pi over 2, and between pi and 2 pi there will be another minimum, which is between pi and negative pi, between pi and 2 pi. Okay, now once the graph is horizontally shrink, now our period is changing to pi. So that means there will be half. So from 0 to pi there will be a maximum value, and from pi 0 to pi over 2 there will be a maximum value, and pi over 2 to pi there will be a minimum value. Exactly same thing, it's just a horizontally shrink. Just remember that this is the easiest way to draw a sine function. So once you draw a line, you have the period, which is end period, which is pi, and half period, which is pi over 2, and between 0 to that half period will be the maximum, and the half period to the maximum period will be the minimum. Okay, I'm just spending time because this will be needed for more things coming up. Thank you very much, and don't forget to like, share, and subscribe.